everybody. I'm Jesse. I do ops at GitHub. I really am kind of a noob at Erlang, but I've been figuring stuff out for the past year or so, and it's gone pretty well. So, my talk today is about GitHub Pages and the work I've been doing to re-implement it on, essentially on Riak and a little Webmachine resource on top of that. So what is Pages? First, I just want to go and give a little overview of what exactly this thing does. So at its core, GitHub Pages is just simple static file hosting. But it's run, the static files or whatever are run through Jekyll, which is a really kind of neat processor that can take textile or markdown input and runs it through liquid templates and generates HTML from that. So essentially, GitHub Pages makes it so that you can add a GH Pages branch to any GitHub repo, and that will get processed through Jekyll and then served over HTTP. And lets you do things like make a little sexy project page for your open source project and show people what it is. And it also lets you, if you have a user.github.com repo in your account, that lets you make a user page. It's just user.github.com. And you can use that to make a silly little blog, or you can use that to, Twitter has a really cool one where they kind of showcase all of their open source software. That actually is hosted on GitHub Pages and uses the GitHub API to load all their repos and show them and show the ones with recent activity. It's kind of rad. It also has custom domain support. So like if you throw a CNAME file in the root of your repo with a different domain name, that will be the all the requests for your username.github.com will be redirected to that domain. And if you point it at the right place, you can serve all of your files at that domain. So you can use this to host, basically whatever you can generate with Jekyll or static HTML. So that all being said, so what's wrong with Pages now? The primary problem is it's very slow and it's been going down a bunch. So I came on to GitHub about, I guess about 9 months ago, and I'm doing ops, so I would get alerts for this thing and wanted to fix it because it would wake me up, and that's not good. And I started digging into it, and I realized there was actually just one node that has a giant ext3 file system that has gigs and gigs and gigs of HTML on it. And it's IO bound, which is any ops person's worst nightmare. It's also been going down a bunch, and because it's one huge file system with tons of files on it, if it ever goes down and needs a file system check, you just kind of sit and hang out and wait for a file system check, and that's not fun at all. And it's one node, so it's not highly available in any fashion. So if there's anything to have to move around the box or do anything weird like that, there's not really much I can do to do it without downtime. So obviously, there's lots to fix. Let's throw it all and start over, right? Maybe not. We've had to scale it vertically a couple times in the time frame. I've been working on a bunch of other stuff, and have just recently kind of gotten back on this. So we've scaled it vertically, but it's time to, we're getting to a point where that's, even on the vertically scaled stuff, it's getting a little hairy. So I want to distribute it and make it not suck. Make it something that I don't have to deal with every 3 months or so. So I started thinking about it top down and thinking about the required functions of the service and what can power each of the functions. So there's 4 things that Pages does when you really think about it. We have to grab content from Git, we have to run the content through Jekyll, we have to write it somewhere, and we have to serve it out over HTTP. So what currently powers that, there's a Ruby queue, a job that grabs the contents of the Git repo, another job that runs everything through Jekyll. That's all written to that giant file system, and it's all served by Nginx. That's great. But the custom domain and redirect support uses this really gross Pages or Nginx map config thing where you can map to, you essentially just create a hash map or a dictionary inside of the Nginx config. And we use that for all the domains that maps them to a path, and that's a 57,000 line config file. Wow. So Nginx does some really weird stuff when you have a 57,000 line config file. Mostly, it just takes a really long time to restart. And it's not that Nginx has nice master, it kills all the processes that are serving the existing requests and flips them around. That's pretty sane, but it just does that really, really slowly now, and it makes it really hard to understand if it's working correctly. So I started thinking about the individual, the parts of this. And I think that number 1 and number 2 are fine in Ruby right now. They're things that our dev team is going to maintain, so I'm going to kind of stick with that. But for the data store, I want to replace the use of the file system as a database, essentially, and that crazy Nginx thing as an application server, essentially, at this point. So we can use Riak to store the data really easily. But we can use some parts of Riak to serve the data. It has an HTTP API, but there's a lot of stuff that we'd have to change about that to make it work. We need, of course, everything to be read-only. We need transactional builds. So if you have a huge repo that has a bunch of movies in it, and you push a new version of your page, you don't want to see half of the old site and half of the new site while you're looking at it. We essentially want to push up the new site and then flip everything over when it's done and is correct. We need to do all the CNAMEs and redirect support, and we also need to kind of emulate the directory index support of normal web servers where you have to fall back or whatever and do index.html, index.htm for those people that are still using Microsoft front page or whatever, and custom 404.html support. So if you drop a 404.html in the root of your repo, we'll serve that if we don't have the object instead of serving our default 404. So those are all things that we'd have to essentially, those are the features above just basic HTTP serving of objects that we'd have to implement. And Webmachine actually fits really well there. All of those things can be implemented in one little simple Webmachine resource that sits on top of KB. So before I get into the details about how all this works, I wanted to talk about why I didn't choose another solution, and one that was kind of talked about a lot internally. People that weren't thinking about it the way I was, I guess, were suggesting kind of a traditional, you can scale out serving of static files by just having a big, slow file server, and then you can put a server in front of that and have a bunch of caching proxies and another layer of caching proxies. And that's legitimate, and that's one way to do it, but then you still have that giant file system. And the giant file systems are something that, as primarily an ops person, they're a pain in my ass. They get in the way of things. They're tough to move around, and I don't want to deal with that. The discussion generally were kind of like this when I was talking to people about this. It's fine. But wait, when you add another server, you have to move stuff around. And, but OK, you can shard them. And then I rage and tell them that they're partitioning things. And then they say, you can just rsync stuff around when you add new partitions. It's fine. It'll be OK. When you're doing something like this, you can say that you're growing a system organically, or you can also say that you're building a distributed system ass first. And I don't want to manage another one of those. So I do ops. Low maintenance, resilient systems make lazy sysadmins love you. And I was just explaining that we have Riak in another place in our infrastructure. And when I need to move one of the nodes around, I just take it offline, and I move it around, and I bring it back up, and I make sure it's in the ring, and all the transfers are done. I don't have to sit there and wait on a slow file system check or rsync partitions of data around. That's more of the operational approach that I like. That's why I implemented this on top of Riak. So how many of you guys are familiar with Riak? I'm assuming a lot. Good, cool. So Riak is a Dynamo-inspired distributed data store with no single point of failure. Boom. So let's talk about the schema design we're going to use to store this data. It's pretty simple. There's 2 buckets, hosts and pages. That's really all there is. That's all that's necessary. So in the host bucket, we store data that's addressed by the HTTP host header of the request that's coming in. And the value of the object there contains a map of repos and their current SHA. We use the SHA of a repo, the SHA of head of a repo, when it's built as kind of a key that we use for the transactional build support. So we use that as a prefix in the pages bucket. Also, if you have a redirect, we store that in there as well, and that allows us to short-circuit a redirect request really quickly before it hits the pages bucket. And we use the Riak secondary indexes stuff to have the user ID index that we use essentially only for GC. That's not used for any request response data. We use that after a build happens to clean up all the old data that's hanging out. That can be slowed or slower than request response stuff, and that's fine. So the data in there looks something like this. Like for jnewland.github.com, I have, just for an example, I have 2 repos here. One that is my main user repo. And the SHA for that, I'm just using short SHAs to make this easier and not wrap. And I have another repo called Pages maybe, and that SHA is stored there. So in the other bucket, we have, the other bucket's called Pages. And the key for that is essentially just a SHA and a URI. The SHA is a unique identifier that lets us kind of prefix and map everything based on what repo it is and also support transactional builds. So if you increment, if you create, if you have a repo and you push something to it, all of the old data will stay there while the new stuff is being written. The new stuff is written, and then we write to the sites bucket to change the SHA so everything, the new deploys happen transactionally, essentially. Same thing, we have an index on repo ID, so we can do GC later to clean stuff up. And the contents of that are just the contents of whatever we're going to serve out with HTTP. It's pretty straightforward. So the data structure is mapped out. How do we get the data in here? So we have a little rescue job that processes things after Jekyll is done with it, that uses the Riak Ruby client, reads files from disk, writes to Riak, updates the site's object in the bucket with the new SHA, and GC's old stuff that's hanging out. And that's Ruby, so I'm not really going to talk about that much. But how does the data get out? The data, before I kind of talk about the Webmachine stuff, I want to think about it just from the HTTP level. I just want to go through like the request response and look at the HTTP and Riak operations first to understand this. So if a browser requested this awesome Velociraptor GIF I have in my blog, that would result in 2 Riak operations essentially. We grab the key from the host bucket that we'll look it up and grab the proper SHA. And then we'll prefix the key with that and request that from the Pages bucket. If I was doing a sub repo, I guess a non-user repo, we'd pull the first kind of path prefix out of the URI and look up in the sites bucket for anything that had prefix of Pages and grab that SHA instead and serve that. So what about CNAMEs? Those kind of have to work differently because they don't, we have to look up the SHA differently for those. So if you had, if there was an example.github.com repo that had a CNAME file in it that said that example.com was the canonical domain, instead of storing the repo to SHA map here, we'd store the redirect, just a redirect key that has the new host that we should use. And in that object, we'd store the same kind of map that we would in the original place. So the conversation, I guess, would look something like this. You grab example.github.com. We'd short circuit any request to the Pages bucket because we would find that there was a redirect object in the host bucket. We'd send a 301 back to the browser, and the browser would request the example.com bucket, and everything would go to the right place. So we have to represent this HTTP behavior on top of the data stored in Riak, so we can use a little Webmachine resource to do that. How many of you guys are familiar with Webmachine and have implemented some stuff in it? Boom. Webmachine is so damn cool. It is HTTP nerdery to that degree, and that's very much my style. If you haven't seen this, you haven't run through it and looked at the decision core code and searched through here for B17 or whatever, it's pretty cool. I recommend reading the code if you haven't. So to flow through Webmachine, you essentially just create a little, you export a bunch of functions that represent decisions in that decision tree that I just showed. So let's take a quick little tour here through some of these decisions in the Pages code and what they actually figure out. So the first thing is service available. My current implementation, this is pretty lame. It just grabs the local Riak client, makes sure it can do that, and then checks an app config variable that I can use to turn it off if we need maintenance. And that's actually kind of legible. These slides will be online. It's really not that good. I'm a noob at Erlang, by the way, so we'll see how that goes. Then we have the malform request stuff. We essentially have to decide if the request is valid. And I take this is the opportunity where I go through and parse the HTTP host header and the URI, and make sure we can tokenize it properly. And we can really easily swipe a bunch of stuff from the Riak Webmachine utilities to do that. And you just catch the exception there and say that it's a malformed request if that ever happened. Content type negotiation is next. This is where we have to emulate, instead of how, I guess, Riak HTTP stuff works by default, where you specify the content type when you're writing stuff in, we want instead web browser style kind of my magic crap that Apache and Nginx do, where we're guessing the content type that we're sending back from the extension on the URI. Because that's how it works now, and we need to maintain compatibility there. So we just, this is it's really simple. We just use the Moki Web, mine from extension stuff, and assume that for things that are at the root, they're probably text HTML. And this is not what's actually in there, because we have a bunch of special cases for people that are hosting like Android builds and stuff on Pages. So there's a big list of extra crap that goes in here, but that's the easy part. And then the critical part of the HTTP decision tree: does the resource that has been requested actually exist? So this is where the first step here, we hit the host bucket to see if there is any page data for this HTTP host at all. If there isn't, we don't have to make any other requests at all. If there is data in the host bucket, if it has a SHA or a redirect, we stash that, and then if there's not, or if there's not anything in the host bucket at all, we just send a 404. So the redirect stuff just stashes the redirect on the context of the Webmachine resource. And if we find a SHA, we move down to this kind of page data exists call that actually looks into Riak and figures out where the data is. If we're headed down the redirect path, well, this is pretty straightforward, because we have to specify that the resource previously existed and that the resource has moved permanently. We don't really support any kind of temporary redirects, so move permanently is always correct if you're there. So we just return the proper URI. We use the same URI, of course, but we just switch out the host. That's the only thing that could ever change in a redirect in this system. And page data exists is really the meat of all the code. That hits the pages bucket. And right now, it does some really, really gross stuff where it essentially builds a list of all of the URIs that it may need to check for this object to emulate directory index support and our custom 404 stuff. And that's kind of a big list. So if you grabbed this URI, we would check all of these keys in order to see if they were there. And that's kind of gross, and that's a blocker for release. I'm going to instead do that on write, and do that same kind of support when I'm reading all the data in Ruby, take a look at all the objects, determine what should be the proper index for the path, and write it to the right place instead of doing this on read. But really, I mean, that's really all that's necessary to implement all the Pages business logic on top of Riak. I started down this path, and then I'd stopped. I had got distracted with a bunch of other stuff, and I came back to it and started doing this presentation and realized that this is really not a lot of code, and this is really a pretty cool pattern for having the same VM power both the little tiny piece of business logic on top of a big chunk of stored data. If you don't have to do a lot of processing on the data when it goes in, like for this, we run everything through Jekyll, and then we write it out essentially as is. I'm going to have to do a little bit of processing on it to do that directory index support, but the logic that has to happen when it's coming out of Riak is actually really straightforward and really simple. And this is a pattern that I'm trying to kind of encourage internally at GitHub. We have a lot of places that use things like Redis for things they shouldn't, and we have single points of failure all over the place. And as we're doing a big data center migration, we're single point of failuring everything we possibly can, and this is a great place to do that. If someone has to implement a little tiny API with some logic around it on top of a piece of data, a little tiny piece of data, they can do that with if I can help some of our developers understand the foundations and basic things about Erlang and basics of Riak, and how to write a simple Webmachine resource, this is something that we could roll out a lot more places. And I feel like the vast majority of the work I actually did on this was kind of getting the build toolchain set up, getting hot code, the hot code stuff in Rebar working. That was way more actual time than actually writing the simple Webmachine resource. So if I can get this kind of pattern in front of some of our developers, I'm interested to see what comes up. So in production, Nginx sits in front of this. We mount this Webmachine resource at Pages, and we kind of hide everything else that's not at that path and proxy everything to it. And that's it. Nginx listens on the public interface. The Riak stuff listens on the private interface. And we can communicate it. Our writer rescue job can communicate with it that way, and everything else only sees the stuff that's at Pages, or /Pages, which is the Webmachine resource. And as I said, I'm a lazy ops guy. This is a really, really simple system to support. There's all the data in Riak, this little tiny resource on top of it, Nginx, and that's it. And I have all the same performance characteristics as Riak, the kind of predictable scalability path. And I don't know, I think it's, I'm really stoked to get this out, and I think it's something that the pattern might be really useful down the road for us internally. Another benefit of this is that now that we have a dynamic server sitting in front of all this data, we can do way more than we could when it was just Nginx. So we've been playing around with some ideas. After seeing Joe Williams talk yesterday, there's a lot of metrics that I can do with this data now, or with these requests, that I really couldn't do with just a simple HTTP server sitting there. It'd be pretty easy to write the internal metrics. I can grab out a Folsom into our Graphite store, and then write some public stuff, maybe some just like hit logs or whatever, into something like gauges. So we could provide people with an interface to get stats for their GitHub project page without doing anything on their end at all. It could just be right there in the repo. I've also been playing with Logger and for some logging. I really don't want, I don't need to do like Apache style logging for everything. There's no real need for that here. But one of the things that I was doing in development, I've added this little logger thing that lets me trace requests for an individual host name. So I can turn off and on logging and actually see stuff that's interesting instead of just seeing this giant spew of HTTP requests that are happening. And a more intelligent server in front of this data lets us do some interesting stuff with HTTP caching, where we've been talking about a lot of stuff where we could use the git SHA of head, or not even of head, but like the git SHA of each individual object that's a part of the page as the E tag for that object when you store it in the database, so that even after a new page build, there's no need to reload the things that haven't changed. If you make a request, you won't have to get the header again or anything like that, which would be kind of nice. And having this ability means that we can do a lot more things with it, and I have no idea what will be next here. So essentially, we're getting really close to shipping this out for a private beta. It's live serving some stuff right now, but it's not serving anything that's super critical, so it's kind of definitely in beta mode. But if any of you are interested in playing around with this, we're planning on open sourcing the server when we're done with it, or at least some parts of it. So if you're interested, I can move any of your GitHub pages over to this if you'd like, and you can kind of flip them on and off with DNS. They'll still be on the old stuff too, and I can, if you want to look at my crappy Erlang code, I can probably get you access to it before we open source it or whatever. So just hit me up on my misspelled Twitter name. So if you're interested in any of this crap, and if you're interested in ops and Ruby and any of that stuff, we're definitely looking for people at GitHub that can kind of help us merge our ass-first distributed system into something that makes sense. There's a lot of work being done there. So thanks, everyone. Any questions about anything?
So, I mean, what sort of performance difference did you see at the end of it?
Well, the current implementation has that ridiculous fallback crap, which means the worst case you're looking for a 404 is really bad. But that's going to be fixed in how we're going to write stuff into it now. And to be honest, there's not a lot that can be much worse than that IO-bound VM that was there for a while. So I think that, I was talking with someone about this, and the performance isn't as good as Nginx on a static file server, for sure. But we confront it with Varnish or front it with a cache there, and not have the giant file system problem that we would have had before. And as an ops guy, I'm more interested in predictable performance than fast performance, I guess, for this product. I want it to work consistently and be able to handle, be able to increase load or increase the capacity we have easily, instead of just throwing a bunch of hardware at it, and if we hit a limit, have to do all this work to move it past that level.
Have you considered replacing Ruby clients with Riak pre-commit hooks?
That's interesting. Replacing the Ruby build stuff with some Riak pre-commit hooks. That's interesting. We have a lot of that stuff that's been in production and working for some time in Ruby, and I want to do as much as I can to maintain feature compatibility with the old version of Pages. I don't want anyone to know that doesn't read our blog that GitHub Pages just switched over to a different system. So I want that. If it's there now and it's working, and not touching it means it will work exactly the same way, and that part works really well. So I think I'm probably going to not touch that for a good while. It'll probably eventually happen, but. Anything else? Yes.
How much, you said you were a relative Erlang newbie, so I'm wondering how much Erlang you had prior to fiddling with Webmachine, and is that a sort of exercise that beginning Erlang programmer should be using as sort of a gateway drug to the rest of the OTP goodness?
I think it's a really interesting gateway drug. I think it doesn't get you a lot of the real kind of the OTP features. Maybe like you can sit in a Webmachine resource and not understand anything about OTP and just think about it in a functional style, and that's the hurdle you could get over with one Webmachine resource. I think it's a great gateway drug for like web programmers out there that they're I guess I kind of grew into programming via being that, where I just figured out what I needed to do to make a website and figure out what I needed to do to make it dynamic, and then all of a sudden I'm writing software. Surprise. So I think that'd be a good way. I think there's a lot of developers out there that function that way, and that may be a good way to shove them towards Erlang. I really prior to this, most of my had a pretty cool training from Erlang Solutions. Did some React Core kind of experimentation with a queue system, but really didn't have a lot of production Erlang experience before this at all. I've read a lot of the React code though. Cool.
Any other questions?
Yeah.
Maybe I missed, but where do you use the React Core?
I really don't so much. I think that was that part of the title was a mistake. I think I meant KV, or maybe I said KV, or I don't know. Cool.
All right, well, thank you so much.
Thank all y'all.